All right, so in this video, I'm going to teach you on how to use Taylor series on this function right here. We've been given the center, which is c is equal to 1. So basically, the few things that we need to know here when it comes to Taylor series is the formula. And the formula looks like this: f of x is equal to f of c plus f prime over c multiplied by x minus a c over 1 prime. So I'll make you understand what I'm doing here. The next thing here, it's f double prime over c, and then actually here we're supposed to have a power 1, x minus c, then here it will be over a 2 prime, then here we shall have a power 2 plus, okay, this is a formula. It keeps on going. Oh, there's plus already here. F triple prime over c x minus c power 3 over 3 prime plus f, what's the derivative of f, and then c here, x minus c power 4 over a 4 prime plus that. Okay, so for Taylor series, you just need to know this formula. It's a pattern. So start with f of c. So here you come and put a prime. You can see what is here, it's the same. Here don't put x minus c. Everywhere there is x minus c, x minus c, x minus c. So it keeps on increasing. So this is 1, and then down here it's 1 factorial. Where there is double prime here, it will be power 2 over 2 factorial plus so on and so forth. Okay, so this is how you go about Taylor series. Once you get to do that, you now get the given function, which is f of x is equal to ln x. So this is a function that we've been given. F of x is equal to ln x. Okay, so this function, we'll start now finding the derivatives. So we can write f prime of x, meaning the derivative of ln. What is the derivative of ln? It will just be 1 over x. That's the derivative. Again, we find the derivative of f double prime. This derivative will of course be negative 1 over x power 2. So let me just run you through how I've managed to find this derivative and this. So what I did, let me start with the first one. What I did over here on this one, I hope you will see. This is what we did, or this is how we get to find the derivative. So normally we say equal to, you come and write whatever is here, that is x, and then you find the derivative of this same stuff, or you just write 1 over what is here, and then you find the derivative of what is down here. What is the derivative of x? It's a 1. And then you say 1 times 1, it's a 1 over x. Okay, so that's how we get to find derivative of ln. We always write a 1. There's a 1 here, write a 1, and then you find the derivative of this. Actually, before you find the derivative, you write this as a denominator and then find its derivative, come and multiply it by the numerator. This is how we get to find. And it's how I found this derivative. For this one, it will be this one. You just use the laws of indices. This will be like this. Okay, there's power 1 here. So the moment it goes on top, it will be power negative 1. So what is the derivative of power negative 1? It will be like this. Negative 1 times the coefficient here, it will be negative 1 multiplied by x negative 1 minus 1. This of course will be, it will be negative 1 x power negative 2, of which negative 1 we just write it as negative, and then x power negative 2. So we can write this using the laws of indices as negative 1 over x power 2. So this is how I got this one. The same process, it will help us find the next derivative or third derivative, which will be equal to, here it will be 2 over x power 3. The next one here, which is the fourth derivative, will of course be negative 6 over x power 4. So these are the 4 derivatives. You can keep on finding, but looking at my formula, I'm ending at 4. So I'll end at fourth derivative. Okay. So once you do that, you can cut like this so that we don't get confused. We can now start finding the f of c. So find the f of c. You put c here. And in the question, they have said c is equal to 1, meaning we're going to put a 1 where x is here and here. So what is ln 1? Ln 1 is a 0. Here we go to the prime. We put a 1 here. It will be a 1 because it will be 1 divided by 1. And then for the double prime, we put a c. It will be negative 1. Here for the triple prime, we put a c here. It will be equal to a 2. And lastly, for the fourth, we put a c. This, of course, will be equal to negative 6. So we've gotten now the coefficients we are looking for. Okay. Applying now these, let me copy them. So we know that f over c is equal to 0. Then here f prime over c is equal to 1. F double prime of c is equal to negative 1. F, then we've got triple there, is equal to a 2. Lastly, f fourth there is equal to negative 6. So now, looking at the formula that we have, this is a formula. I don't want you to mess up. This is a formula. So we can start plugging in. So we shall say ln, okay, of x is equal to, okay, what is our f of c? F of c is 0, so we're going to say 0, and then plus. Here there is a 1, so we put f over c here, it's a 1. So we're going to remain with x minus a c is a 1, then power 1 right here. Plus. Here it will be, actually it will be minus, not plus. Okay, you can say minus, plus, negative 1. Okay, this negative 1 multiplied by x minus 1 power 2 over 2 factorial. Okay, so you can see this, of course, is the negative, which is right here, and we copy this, everything the way it looks, plus a 2 open bracket x minus 1 power 3 over 3 factorial, and then plus negative 6 x minus 1 power 4 over 4 factorial plus okay. And then if you see nicely, this will be ln, if we simplify, of x is equal to x plus, should I say minus 1, x minus 1 minus a 1, or should I say minus negative x minus 1 power 2, then 2 factorial here, plus a 2x minus 1 power 3, 3 factorial, minus 6x minus 1 power 4, then 4 factorial, plus, like that. Okay, so this is what we have. It's the Taylor series of this function right here. Thank you, and bye-bye.